All right, so now we're going to deal with the power rule. So this is a very powerful rule, and I try to get most of the problems to get to this form so we can use it. So basically, if we have a function in a form, f of x is equal to x to some value k, where k is a real number, we're going to call that a power function. Now, the following here are examples of power functions. So here you have x, and that's really, if you think about it, that's x to the 1. Here we have x squared, x cubed, x, and this is the square root of x. Well, think about that as x to the 1/2. Here we have the cubed root of x. Well, that's x to the 1/3. And then we have x to the -3. And sometimes you'll end up and you'll start with x to the third in the denominator, and you rewrite it into this. So then you can actually take and use this power rule, which we're going to see here in theorem 2. And basically what it says, if you have some y or f of x, and that's equal to x to the n, where n is the real number, then the derivative of this is going to be, what we're going to do is we're going to take that n down in front, and so we have the n in front, and then we're going to subtract 1 from our power. And so y prime is just n times x to the n minus 1, and dy dx is again n times x to the n minus 1. So no matter what we do and however it's represented, we're just taking whatever the exponent is, bringing it down in front, and then subtracting 1 from it, and that's our new exponent. Okay, so properties of exponents must be used to rewrite an expression before the power rule is applied in some cases, as I have showed you here, here, and initially it would probably have been written like that, and then it would be rewritten to that form. Okay, so once we get it into the form, we can use the power rule, some x to the n, then things get really simple. All right, so let's do some examples here. So this one for a, we have f prime of x is going to be equal to what? Well, our power is 6, so we're going to bring that down in front. So we'll have the 6x. Now we're going to take 6 minus 1, and that's going to be 5. And so our derivative is just 6x to the 5th. Okay, similarly on B, now we're going to say, well, instead of f prime of x, it's going to be y prime. Well, now it's in the right format, so we're just going to take our n, bring it down in front, so we'll have a 30x. Now we'll take 30 minus 1, and so that's going to be 29. All right, let's do C over here. All right, so that's going to be dy dt, and that's going to be equal to what? Well, it's in the right form of some x to the n power. So now we're going to take that power, bring it down in front. So it's going to be a minus 2t. Now we're going to subtract 1. So minus 2 minus 1 is going to be a minus 3. Now here, we could leave it as that, which is fine. Or sometimes they'll say, well, write it with only positive exponents. And so that would be a minus 2 over a t cubed. Okay, so either way, both of those represent the same thing. Now for d, here we're going to have d dx of the x to the 3/2, and that's going to be equal to what? Well, here we're going to take the exponent again, bring it down in front, so that's going to be 3/2, and then we have x. Now 3/2 minus 2/2, which is also 1, is going to be 1/2, and so that would be one representation. Now we could also write it 3/2 square root of x. Either way, it's the same representation, just different way to look at it. Okay. All right, let's look at some more. Here we want to find f prime of x, the derivative. Well, again, this one is not written as a x to the n, so we're going to have to rewrite this as x to the -1. So for a, f prime of x is going to be what? Well, now we're going to take that -1, bring it down in front, so we'll have a -1 x. minus 1 is going to be a -2. And again, rewriting it, that'll be a -1 over x squared. Okay, so both of those are going to be a correct answer. Sometimes they want it back with positive exponents. That's the only difference. All right, what about b? Well, really, this is really u to the 2 over 3, because that's the power, that's the root, and the root goes in the denominator. And so that's what it initially is. And so now when we take the derivative, we'll bring that down in front. So for b, I guess we just do it here. Y prime is equal to 2/3 u. 2/3 minus 1 is going to be a minus 1/3. All right. And so that would be the derivative in one format. Now, if we wanted to make this a positive, that's going to be basically a 2 over a 3 for this part here. Now this is going to be the cubed root of u, so that's going to be the cubed root of u. Okay, and so that's how that one would be represented with the positive exponent and also back into the root format. Now, what about this one? Well, this one is right now, as it's written, 1 over x to the 1/2, but we need it to the x to the n, so that's really x to the minus 1/2. All right, so now we can take that derivative. We'll bring that down in front. So for c, d dx, and let's just call it our f of x or whatever it is equal to what? Well, it's going to be a minus 1/2, and then it's going to be x, and we have minus 1/2, minus 1, so it's going to be a minus 3/2. Okay, so that's one representation. Another representation, we can have the numerator, which is going to be a minus 1 over 2. Now this is going to become a square root of an x cubed. So it's going to be the square root of x cubed. Okay, and so that's where we could leave it at that point in time. All right, so let's stop there and then we'll come back for some more.